In this example, we have to determine the exact value for cos x, sine y, and then the exact value for cos x minus y. But in our question, they've given us some information. So there's a lot going through here. So let's highlight or underline some of the important pieces and where they fit together. So let's start off with this first bit. So we're talking about how angle x is in the first quadrant such that sine of x equals this piece here. Okay. Everything else talks about y. I'll use a different color for that. Angle y is in the second quadrant such that cos of y equals this. Okay. So I have to take a look at each different piece depending on what we're asking. Because when we have been asked to determine the exact value for cos of x, we can, if we're dealing with x, we are going to be talking about this information here. Where in part B, they asked us to determine the exact value for sine of y, we would only be dealing with this green piece here. So let's take a look at A. So determine an exact value for cos of x. Well, they told us that sine of x is equal to 8 over 17. Well, let's just remember that sine of theta is equal to y over r, and cos of theta is equal to x over r. Because if sine of theta is y over r, that means this is my value of y, and this down here is my value of r. So since they are both positive, and that I am in the first quadrant, let's remember which of these are our quadrants. Well, up here, this is our quadrant 1, it's our quadrant 2, quadrant 3, and quadrant 4. They're always denoted in Roman numerals. So they've already told us that the angle x is in the first quadrant. So I'm going to be living in here. Okay, I don't know what that angle is. Okay. We just know that this is my angle x. Okay. The next piece tells us that this is my y component and this is my r component. So let's do step 2 where we draw it out. Let's make that straight up and down. There we are, to make my special triangle. And now we can label my y and my r. Well, my r is going to be 17. So remember, that's this piece here. Because we can remember that this is my r, that is my x component, right? This is my angle x, but this is my x component, and this is my y. Well, they told us that y was 8, and r is 17. But the issue here, we need to determine the exact value for cos of x. Well, let's look back. Cos of x needs my x component and my r. Well, I've got my r as 17, but I don't know what this is yet. But so we have 2 sides here, but we're missing my third side, and I need that to complete this ratio. Well, this is a right angle triangle, right? So that means I can use my Pythagorean theorem, remember a squared plus b squared equals c squared, to solve for that missing side length. But in my case here, it's going to be x squared plus y squared equals r squared. And we're going to be solving for that missing x because that's the piece we don't have here. Okay. So I'm going to solve for this because that's my missing piece right there. So let's plug in my numbers. I don't know what x is, so that's what I'm going to be solving for. But my y is 8. and my r is 17. So 8 x squared, 8 squared, 8 is 64, and 17 squared. 17 squared is 289. So when I bring over that 64, 64 will come over here. Give me x squared will be equal to 225, because it was 289 minus 64. And when I square root both sides, that will give me an x value of 15. All right, well, that means this x is equal to 15. So now I have everything I need to complete my ratio for cos. So that means cos of x, cos of this angle x, would be my component here, 15 over r, which is 17. So that is the exact value for cos of x. So we're now going to follow that same process for angle y. Well, they have told us that angle y is in the second quadrant. So y is going to be hanging out over here somewhere, which means from here to here is my angle y. Actually, I'll put that in here. That is my angle y. So when I then move on to try and label some of my sides, we'll connect it down to the bottom, just like normal, to make our right angle triangle. And now we can label our sides. So cos of y here is 24 over 25, but we notice that this is a negative here. Okay? Well, cos deals with x over r. So this is my r value down here, but I'm not really sure where to put this negative. Well, since this is x up here, that's my r down there, when we're looking over here, my x component is negative, right? This is where all the negative x's would have been, because this can be rewritten as like my x-axis and my y-axis, right? Well, on the x-axis, these are all negatives. So that means when I have my x, y, and r, this x value is actually going to take that negative with it. So that x is actually negative 24. So that's why, I'll try to write that a little nicer. That's why that negative is here, because it's not going to attach to the radius, because the radius, or r, is never negative, ever. Okay, so this is always a positive value, but this is negative because in the second quadrant over here, this is where my negative x's are. Okay. So I've got almost everything I need, but they've asked us for sine of y. Remember, sine is y over r. Now, I don't have my y component, so I need to use my quadratic formula again to solve for that missing piece. Remember how we did that over here? That was my missing 15. That was right there. So we're going to use the quadratic formula again, but we're going to use it for this one. Okay, so I have my x squared plus y squared equals r squared. Now let's plug in my numbers that I have. I have my x, so this is going to be negative 24 squared plus y squared. I don't have that. That's what I'm missing, right? This is my missing y coordinate for my ratio. So I'm solving for that here. Equals r squared, and my r is 25. Okay, so what do these give us here? So 24, negative 24 squared, anything that's negative but to the power of 2 will make a positive. So this is in fact 576 plus y squared equals, and 25 squared is going to be 625. All right, now we're solving for this y. So that's going to have to come over, leaving me with y squared to equal 49. And when I square root both sides, that will give me a y value of 7. So that is my missing piece that I need for my sign ratio. Now, the question might be, well, when we square root something, it could be a positive or a negative value, and you'd be right. But it all depends on what quadrant we're in, because up here, my y is positive, right? This is where the positive y values are. If we were living down here, if they told us that this ratio was in the third quadrant down here, I would have used the negative 7 down here because my y's are always negative down here. Well, that's just something to keep in mind and to pay attention what quadrant we're in. So let's finish up by writing the exact value for sine of y. That means sine of y is actually equal to my y component, which I just got, which was 7, divided by my value of r, which is 25. So that is, in fact, the exact value for sine of y. We don't know what the angles x and y are, but it doesn't matter because they've given us enough information to solve for the ratios anyway, to solve for the exact value without knowing the angles in general. Okay, but we wouldn't be able to do this if they hadn't given us this information. Okay, so let's finish this up with part C. We're going to determine an exact value for this compound angle formula. So first, let's write out the compound angle formula. So cos of x minus y is equal to, remember cos always has the two coses first. So it's going to be cos x, cos y, and then the signs are actually opposite. So even though this is a subtraction in here, this will be an addition out here. So with coses, the operation is opposite. Or if you have one of your sine compound angle formulas, the operations are the same. So just a little way to help you memorize or remember what these are. Okay, so this is my compound angle formula, and now I am lucky enough that I actually have the exact values for each of these pieces, right? Cos x, we solved for, right? Cos y, they gave us. Sine x, they gave us that too. And sine y is what we solved for. So let's just plug in my values. So what did we get for cos x? We solved that to be this value here. So we solved cos x to be 15 over 17. Okay. Well, cos of y, they gave us right away, right? It was negative 24 over 25. So that came right from the beginning, that highlighted green bit. Okay. Plus sine x, which they gave us as 8 over 17. So I'll highlight that in blue because that's what they gave us right here. And finally, sine y is what we solved for right there. So we solved that to be 7 over 25. Okay, so we don't have to solve for any of these angles x or y's because we already have all of the exact values right here. So now we're just going to clean up and simplify. First, we're going to multiply these fractions, and when we do that, we multiply the tops and we multiply the bottoms. So when I do 15 times negative 24, that gives me negative 360 over 17 times 25, which is 425, and then plus 8 times 7, which is 56, over 17 times 25, which is 425. So if I'm adding these two fractions, that means they have to have the same denominator, and they already do, 425, so that's awesome. So I can take this negative 360, add 56, and I get negative 304 over 425. So that right here is the exact value of cos x minus y.